Welcome back. Today we're starting section 4-5, so dealing with quadratic equations. And today our learning target is to solve quadratic equations by factoring. So the idea is now we're not just factoring. Now we're going to see how does this apply to actually solving quadratic equations. So, solving quadratic equations, we're trying to find the zero of the function. Now there's a lot of ways we can notate that. So they can be called the solution, the zero, the root, the x-intercept. All of those things are asking us to find the solution, okay? So all those words are synonymous to what we're doing today. Now, the way that we do it is something called the zero product property. Okay, that's the key of how we apply factoring. All right? So, ultimately what we're looking for is the zero product property states that if two things multiply to be zero, that means one of those things actually has to be zero. You can't take two non-zero numbers to multiply to be zero. It's not possible. So if we can get two things multiplying to be zero, that means if we solve either piece being zero, that gives us the solution. So let's do a couple examples of the zero product property. So here I have two things already in factored form, okay? We're going to start off basic, work up to being more difficult. So here, what you're going to do, I see two things multiplying to be zero. So I'm going to take each piece and set it equal to zero, because what that zero product property says is that means both pieces could be zero to make this work. So it means my solution is x equals -5 and x equals 7. Okay, so again, it's really easy. It's basically just the next step from factoring. But you have to make sure you remember you take each piece and set it equal to zero. So here again, I see two things that are multiplying to be zero. So I'm going to take both pieces and set them equal to zero. So here, that means I'm going to add 3 to the other side, divide by 2. Feel free to leave it in fractional form like that, by the way, okay? You can just leave it as 3/2. Here, add the 9 over and divide by 4. So that is all that the zero product property says, okay, is set each piece equal to 0 and solve. Now, for the most part, we're not going to be getting things that are in that simplified of a form, right? We're going to get quadratics in standard form. We're going to be asked, find the solutions. Now, what that means is that we need to factor first. Because remember I said those two we just did were already in factored form? Well, that means we have to get these to factored form. So, we're going to have to go like that. All right? We need to factor these. Now, again, I'm not going to spend that much time on the factoring piece anymore. We just spent 3 days on it, so you guys should theoretically be good at this. So I'm not going to spend that much time reminding you how to get that x and x. Now to get 6, you're talking about 1 and 6 or 2 and 3. If you're multiplying to be positive, but adding to be negative, it means you need two negative numbers. Then the one that works here is a 2 and a 3, because that'll give you the -2x and the -6x, or -2x, -3x, which combine to the -5x. So again, starting from here, I'm going to start going a little bit more quickly through the factoring process, because my goal is that you should already be good at that. Now we're ready for the next step. The next step after you factor it is now taking each piece, setting it equal to 0. All right, so here our solutions are x is 2 and x is 3. All right, what about this one? Again, the goal is we need to factor it. Now, what I'm noticing though is I have two terms being subtracted, and that 100 draws my attention because it is a perfect square. So with this one is the difference of two squares. All right, so that's where you need to remember to put in the plus and minus. X squared comes from x and x. That 100 comes from 10 and 10. And now I have two things that multiply to give me 0. So I need to set each of them equal to 0. So x equals -10 and x equals +10. So again, pretty straightforward. You learned this back in Expo, but now it's just remembering how to take it beyond the factoring to actually solve these quadratic equations. Now, one key though is that the quadratic equation has to equal 0. It's the only way that the zero product property works, is if it's being equal to 0. Otherwise, the whole thing falls apart. So what that means is if it's not equal to 0, you have to make it equal to 0. So what that means is I have to subtract the 14 over with everything else to get it equal to 0. Okay, so you have to get everything to one side of the equation. You need everything on one side so it equals 0. And now I can go through my factoring process. How do I get 3x squared? Well, that's going to be 3x and x. How do I get 14? Well, 1 and 14, or 2 and 7. I notice it's negative, so I know I'm going to be using one negative and one positive. So that means I want the difference of the numbers I'm looking for to give me that 1x in the middle. So now let's plot the numbers in appropriately. So I'm just going to jump to the right one to show you 7x and 6x. Well, and I'm looking for the difference because I know that one of my numbers is negative. It's going to be the -6x. So I get a plus and a minus there. So again, not spending that much time on the factoring anymore because the goal is now taking it beyond. You should already be good at the factoring. And now that we have our factored form, we have two things multiplying to 0. So I'm going to set each of them equal to 0. So I'm going to subtract the 7 and divide by 3. This one, I just have to add the 2 over. And I get my two answers. All right, let's look at this one. Once again, not set equal to 0. So my first step is subtracting the 15 over, collecting everything on one side. So now I can use the zero product property after I factor this. How do I get 2x squared? Well, I get 2x squared with a 2x and an x. How do I get 15? Well, with 1 and 15, or 3 and 5. Now, the thing that I notice is that the 15 is negative. I'm multiplying to a negative number. That's only possible when I have a negative and a positive. So I need the difference of whatever I find to be 7x. Well, Let's try that 3 and the 5. Again, I'm going to jump to what I know works just to make this video shorter, alleviate that kind of trial and error checking so you can see what the right answer looks like. Well, here we have 3x and 10x. And again, because we're multiplying to that negative 15, I need the difference to be negative. Or the difference to be 7x. I need one of these to be negative. So I put the negative with the 3x, and that gives me the positive 7x that I need. Now I have two things multiplying to be 0, so now I can use my zero product property. So add the 3 over and divide by 2. Subtract the 5 over, and there you go. We have our answer. All right, last example of this type that I want to do with you. So already set equal to 0, so that's awesome. Everything's already on the same side. So let's begin our factoring process. That 4x squared, well, now we have an issue because remember 4 and 1 or 2 and 2 can work. So here, remember, is that instance where you have multiple things, multiple structures you can begin with. All right, so you have to keep in mind that potentially either one of these structures could work. Having 4x and 1x or 2x and 2x. You have to keep in mind to be checking both of those, okay? Then the 9 is either 1 and 9 or 3 and 3. Okay, now again, I'm just going to jump to the right answer to show you what the right answer looks like. You would have to go through and do the methodical trial and error to get to the right answer. I'm going to do 2x and 2x, then minus 3 and minus 3, which you should recognize right away that you need two negatives because you should be seeing that you're multiplying to be positive yet adding to be negative. All right. So we have this properly factored. And again, I can tell that because here is negative 6x, which does give us that negative 12x that we're looking for. So this is factored properly, but I'm not going to make you watch me go through the methodical work. I'm just going to show you what the right answer looks like. And so in this case, I have two of the same thing, all right? So if I have two of the same thing, I don't need to solve that same thing twice. They're going to give me the same answer, okay? So because it's giving me the same answer, all I have to do is solve one of them. And what it means is that this is what's called a double root. I'm getting two of that same solution, okay? But again, I'm not going to make you solve it twice because that would just be silly. It's the same thing being set equal to 0 twice. So you can just give me the answer once, all right? We'll talk more in Chapter 5 what that actually means, okay? Because that is something very special, very unique. But we're not going to dive too deeply into it until Chapter 5. The last thing I want to show you, okay, the last thing I want to make a connection on for us is I used a lot of synonymous terms. Zeros, solutions, roots, x-intercepts. Now the thing I want to focus on is the idea of x-intercepts. Okay, when we go through, we factor it. We use a zero product property. So this is one that we did back on that first slide. Okay, we got two answers, an x of 2 and an x of 3. Okay, that's what we found when we used the zero product property on this. I want you to look graphically what's happening. Well, graphically what's happening is notice those two values are where it's crossing the x-axis. So when you're finding these solutions using the zero product property, what I want you to understand graphically is that that is where the parabola is crossing the x-axis. You are finding those points of intersection in an algebraic way. Okay, that's what I really need you to understand. And again, more of that is going to come back in chapter 5 for a deeper understanding of this, but I want you to see it now so then you'll understand more and at a deeper way when it comes back. But just to understand, whenever we're finding these solutions, these zeros, what you're actually finding graphically is the x-intercept of these parabolas. Okay? But now what I want you to do is I want you to go write that summary for me, please. Summarize these concepts, write any questions you have for me, and then just make sure you come back ready to do your practice work in class tomorrow.